I like going by the name Atieno Ouma, but I find it that most of my friends don't know how to pronounce it. Somebody told me my last name means grandma in Dutch, so when I'm in the Netherlands, I don't go by the name Ouma, because they'll be like, whose grandma are you? But it's fine. Also, a fun fact, this is my very first tech event attending without a head wrap. And today when I was video calling my mom, she was like, Atieno, are you naked? Because they're not used to this, and it's also new to me. I got trained on, and my head wrap was a bit soaked, but it's okay. So yeah, as I said, I'm Atieno Ouma, and I'm a backend developer working with a USAID funded project called Health IT, and what we basically deal with is data. So that basically tells you that I'm much into the data. I do the backend development, and I develop the data pipelines. And during my free time, I try to play around with machine learning technologies and solutions, and mostly I like to play around with Google machine learning solutions. So recently there was a challenge by Google and Kaggle to do ASL transcription, and they provided a very big data, a very big data set that they wanted people to develop a model that will do the real-time transcription of American Sign Language, And I actually did participate in that competition, and I did a model, though it didn't do so well. I was nowhere in the leaderboard, but it's fine, I mean. Yeah. So why do I want to talk about American Sign Language? The way we are here right now, we are a community. And a community consists of dynamic people from diverse backgrounds with diverse abilities. And just a quick one. Has anyone ever attended a talk where the speaker was either deaf or mute? Were they using technology to help them to deliver their talk? How did they go about it? For those who raised their hands, yes.
It was a person who became deaf later in life.
Yes.
So she spoke. She didn't use any assistive technology.
Okay.
She hadn't grown up deaf. She became deaf later in life.
Later, so she could still talk.
Yes.
Okay. Yes.
It was someone who had someone else who was speaking with them or for them, so they were signing, the other person was speaking.
He was speaking, yes. Personally, I've never attended a session that has had a deaf or mute speaker, but then we do have them in our communities. And sometimes they feel left out because also their needs are not catered for. You find maybe you have a deaf person attending, but then nobody is doing the translation. Nobody is transcribing whatever is being spoken. Or maybe, okay, for this, in this case, they will obviously be able to see, yeah? But then what if now they want to speak and they want to communicate with you, but then you don't understand sign language? So yeah, that's why I think we really need to talk about it in our communities and how we can address this diversity issue. So these are language that is used by the deaf or the hard of hearing community. Yeah. So its importance I've already mentioned, and also just running some statistics. We have like 5% of the world's population is deaf. It might look like a negligible number, but then at the end of the day, it adds up. Yeah. Yes. So what I wanted to take us through, which I've been told I have 25 minutes. I'm not so sure if we'll be able to do the demo because I had something running, but it's fine. So I want us to look at how we can use these three technologies to be able to transcribe American Sign Language in real time. So I'm going to use Python as my language of preference, and then I'll use a bit of scikit-learn. Okay. I must have forgotten to add OpenCV that I'll use to capture the frames. and do the analysis. And then the main technology that I'm going to cover is MediaPipe. So MediaPipe is a solution by Google that enables you to, TensorFlow. Yeah, so MediaPipe is an open source framework that you can use to build pipelines to perform computer vision inferencing. So it has a number of things you can do with it, and you can use it on a variety of media. You can use it on video, you can use it on audio, and apparently you can also use it on images that has, you can also use it on images, and it's built on top of TensorFlow, which I am sure most of us are very conversant with, those of us who are in the data space. So yeah, how does it work? You just take an image or a video of somebody with their hands. Remember, these are ASL. ASL involves the hands. And then, first of all, you have to identify the hand, right? You have to tell, if this is me, this is Atieno standing here, where are my hands? They're right here. You have to identify where my hands are. Once you've identified them, you have to identify the vertices in my hands. If I've folded my hands this way, you have to identify all the vertices within it, convert it to a format that computers understand, and then try to classify and see if you really, if your model really got what you wanted to achieve. Yeah. So before we go to the solution, MediaPipe has a number of what do we say? Endpoints that you can port into. So there's one that does face detection, there's one that does face mesh, iris detection, hands detection, and pose detection. So the ones that will be particularly interesting to us is the face mesh. I'm aware you know that sign language does not only involve the hands, it also involves the facial expressions, it involves the poses, the movements, not just for the word, not just for the alphabets now, but just for even the words, right? So there are a number of solutions we can tap into to do the ASL transcription, and particularly the face mesh to identify the emotions, and then the pose detection and the hand detection. Those are the particularly important solutions for us. So, yeah, an ASL transcription model is a model that can be able to identify American Sign Language if you give it a media, be it video, be it an image. And I'll be using SVM to do the classification, and of course OpenCV to capture the frames. So, yeah. So how MediaPipe works, we are going to use the hands functionality of the MediaPipe. So we are going to extract the hands from the image, as I said, and then, of course, if it's a video, you have to track the movement of the hands, and then we'll use SVM to classify, and then give the output that we believe is the right one. So if we look at this in terms of code, so you can see, I should have included a code that was importing the MediaPipe itself. So initially I had to import MediaPipe as MP, so that when I come here and initialize MP solution.hands, so there's this function called hands that can actually be able to track your hand in real time on your screen, and you can be able to see it. So the essence of using this, instead of focusing on writing the algorithm that does the tracking of the hand, why don't you focus on fine-tuning your data to be able to do the transcription better? Somebody is already doing the hand tracking, the pose detection, the face mesh. Why do you need to go through all that trouble to do that? Yet you already have solutions that do that for you. So that's the good thing about this. And also with this you can be able to tap into, how do we call it? You can be able to tap into these solutions to build faster and even better, and you can be able to do extended machine, it's called, what's the name? Why is it skipping? I'm sorry, I think I'm a bit nervous. Yeah, so let me explain the code first. So after you've initialized the hands function, you have to tell it what type of media it's using. So it's a static image. So for this demo, I used a image data set. So I have to tell it what type of media it's dealing with. If you're dealing with video, you also have to state that. So it's a static image. And then the maximum number of hands I've initialized as 1. So, sorry. After that, now I have to do I have to retrieve the data points in the hands, the vectors of the hands. So that when I put my hands in front of a screen and maybe do something like this, it will be able to draw all the vertices and know, okay, what sign is this in sign language? Does it have a meaning? Anyone? Sorry? Sorry? Okay, let's find out. So yeah, and then I told you I'll be using OpenCV. So initially I had imported OpenCV and initialized it at CV2. So I'm using OpenCV to read the images from a path that I had already declared elsewhere, and then I'm transforming it into. I'm transforming it into my goodness. Sorry about that. So yeah, I'm transforming it into numbers because computers only understand numbers, they don't understand the images. So you have to do feature extraction and all that. And the good thing is that OpenCV already does that for you, so you don't have to go and do all the work by yourself. And you can just focus on doing the transcription itself, not reinventing the wheel. So we get the landmarks that are in the hands, and then we return it as the hand data points, and then we store it somewhere. So once we already have the data points of the hands, we now want to come and develop our model or train our model. So before that, you have to do the data labeling, which I won't go much into, part of the data pre-processing. I just wanted to come right to the model itself. So we are using a linear classification model, SVM, and then we are telling it to first of all, you have to fit and reshape your model. And while you're doing that, you have to put into consideration overfitting, underfitting, and all that. And then once you call, okay, the model is just to create an ini based on the SVM classifier. So once you create your model, you have to save it somewhere else and you'll come back and use it as to do the classification. And before you actually use it for the classification, you have to evaluate its performance. How is it performing? What are the false positives? What are the false negatives? And what percentage are these false positives? What percentage are these false negatives? So you can actually, there are a number of evaluation criteria. There's the precision score, there's the recall, there's the F1 score, which is it's a ratio of the precision recall and F1 score. And then now we look at the support. So this model that I trained, you find that, first of all, do you understand precision and recall? What is the difference between precision and recall? Because these two are the, people tend to, how do I put it? People tend to confuse between precision and recall. What's the difference between precision and recall? Anyone? Do we have data scientists in the house? Yes, what's the difference between precision and recall?
So recall is the number
Mm-hmm. Anybody else with a different opinion? Anyone? There's this data scientist from Spotify, is it Alan? Yes.
I kind of Googled it, but precision is true positive divided by actual results.
Mm-hmm.
Recall is true positive by
Predicted results. And these are very important metrics when you're testing the performance of your model. You have to know if your model is giving you negatives or if it's giving you positives, which are very false. And you have to know how to, based on these metrics, you can come back and reshape your model, retrain it, iterate through, and get exactly what you need. So in this data set that I used, actually, if you look at these alphabets, you can realize that there are some alphabets missing, right? Which ones are missing in this list? Sorry? J, Which other one? Z, okay. Yeah, sure. So J and Z are missing. Why? These are two letters that involve a bit of motion, and the data set that I was using in this instance was an image data set. So it cannot be captured in an image. So a better way to do this, first of all, training a model with image data set can be a base, and you can do transfer learning when you have like video data set. But first of all, you might want to have a model that can tell this is a A, this is a B, when it's static. And then based on that, you can do, based on the knowledge your model has, you can transfer this knowledge into a video data set. So identifying the images the letters is the first step. And then maybe later on now, if you want to do like the real time, it involves motion and transitions. Now you can come back and put in video data sets. But for this instance, I just used the image data sets. So I wanted to do a short demo, but then you know demo don't usually go well when you're doing it live. So may the demo gods be with us. So I'm told I'm almost running out of time, but I really wanted to do the demo. So I do have a number of files here. I have a file that is doing the data manging or the data pre-processing. I have a file that is doing the model creation, and then I have a file that I'm using to do the prediction. Okay? So why did I do all this? I had this in a notebook, but then I wanted to like have a sort of a desktop application. I wanted this to fire up on my camera so that we can see if it's really working. So probably we can try. Okay, perfect. So the problem is, in my model, I had told it to identify just one hand. You remember where I had specified the number of hands? So if you want it to identify as many number of hands as you want, you just specify. So you might be having two speakers speaking at the same place at the same time. So you might want to identify the, you have to specify the number of hands that you want your model to be tracking or your application to be tracking and transcribing. So right now, as you can see, this is MediaPipe. Remember I used the hands model, right? MediaPipe has all these models, but I only use the hands model for this. So it does real-time tracking of my hands. Now, based on this is not what I did myself. This is MediaPipe. So based on this tracking of the hands, you can actually be able to tell how do I call it? What alphabets this person was communicating through, and it's supposed to come here, predicted class. I'm not so sure why it's giving me a space. It's supposed to give me the letters it thinks that I have spelled. Is this spell or said? So probably I missed something when I was doing the data manging. Probably I missed the data set. So now it has nothing to check against because I just ran it a few minutes before I came here. But yeah, as you've seen, this is the power of like pre-trained models. You don't have to go and reinvent the wheel. Somebody has already done this for you. You can, actually it tracks. Now what you have to do, you have to make sure you have a data set that it can be able to reference against to try and see if this is the sign that you're making. And I have a notebook, but it takes a few hours to run. I really do have a notebook that does all these, but I tried running it, and the training iterations will be too much. But let me just... So this shows the landmark of the hand. So this what I did using the dataset that Google had provided in the Kaggle competition. And I was actually trying to trace the hands first, the hands and the poses. So as you can see, this is an image I took from, it's a frame I took from the video, tried to identify the vertices, and then tried to tell which letter it was. So if you try to see, it's tracking it real time, because this is a video data set. And when it comes to a video data set, you handle the frames differently. So, yeah, actually, I would have loved it if this model actually gave us the letters, but it's okay. I mean, they don't usually work out. So, any question?
I think that was Grace under great difficulty with the starting being delayed. So thank you very much.
Okay.
Anyone with a question? Rob, because you're in front of me.
How soon before we can use this to hear a presentation from somebody who would be using ASL to present, do you think? Sorry? How long do you think it would take before we can attend a presentation by somebody using this method?
Okay. So I already have a model that is doing this. If you want it, you can see me later, and I can give you the model. You can put it in your website, your application, and you can use it to broadcast live, you can be able to broadcast live ASL transcription. So the model is already there, just have to rerun the notebook and export the model from Kaggle. But yeah. And I'm sorry if I was speaking a bit slow. I know you are used to people speaking English faster, so probably in your head just do a forward play.
Thank you very much indeed.